The universe is supposed to follow rules. Gravity pulls. Time moves forward. Light travels at a fixed speed. But what if those rules don't apply everywhere? Across the cosmos, there are places where reality starts to bend, where the math stops working, where the laws of physics don't just break, they shatter. From collapsing stars to cosmic rips in spacetime, these locations challenge everything we thought we knew. In this video, we'll explore the top 5 places in the universe where physics breaks down, and by the end, you might question whether the universe was ever normal to begin with. So buckle up. What you're about to see might twist your understanding of reality itself. Don't forget to like, share, and subscribe if you enjoy venturing into the unknown. The core of a black hole. Let's begin with a place where physics doesn't just break. It completely disappears. The core of a black hole, also called the singularity, is perhaps the most mysterious place in the known universe. Why? Because here, everything collapses. Space, time, matter, even the laws we thought were unbreakable. At the singularity, gravity becomes so intense that it warps space to an infinite degree. That's not just poetic, it's mathematical. According to Einstein's general relativity, as mass compresses into an infinitely small point, spacetime curves infinitely. And when curvature becomes infinite, physics has no answers. Imagine this. A star several times bigger than our sun collapses in on itself. Its outer layers are crushed. The core is compacted into something smaller than a grain of sand. And yet, it weighs more than multiple suns combined. At this point, the force of gravity is so overwhelming that not even light can escape. And what happens at the center? We don't know. No telescope can see it. No signal can leave it. And no current theory can fully describe what lies inside. General relativity tells us the gravity is infinite. Quantum mechanics says that can't happen. 2 of the most trusted scientific frameworks in total disagreement. That's why the singularity is more than just a mystery. It's a message, a signal that says, our understanding is incomplete. Some scientists believe it could be a gateway to another universe. Others think space and time themselves cease to exist there. But one thing is certain. At the core of a black hole, the laws of physics fail. And the universe doesn't apologize for it. The surface of a neutron star. If you thought the core of a black hole was intense, just wait until you get near the surface of a neutron star. Born from the collapse of a massive star, a neutron star is what remains after a supernova. The outer layers are blasted into space, and the core is crushed under its own gravity. But crushed how much exactly? Imagine this. A single teaspoon of material from a neutron star would weigh as much as a mountain, nearly 4 billion tons. That's the kind of density we're talking about. The gravity is so strong that if you dropped an object from 1 meter above the surface, it would hit the ground at over 7 million kilometers per hour, almost 2% the speed of light. But the madness doesn't stop there. The magnetic fields, 1 trillion times stronger than Earth's, strong enough to distort atoms, tear molecules apart, and literally rip the quantum structure of matter. In fact, some neutron stars are so magnetically violent that we call them magnetars. If one were just a few hundred kilometers away, its radiation could erase every credit card on Earth, and that's if you survive the gamma-ray burst. Now imagine standing near one. Your body wouldn't just be flattened, it would be atomically unraveled. Electrons stripped from nuclei, matter turned to energy. It's not just hostile, it's unreal. And remember, all this happens on the surface, not inside, just the outer shell of the star. The laws of matter, pressure, electromagnetism, they all start to blur. We have no way to replicate those conditions on Earth. No lab, no collider, no machine even comes close. That's why the surface of a neutron star isn't just a frontier. It's a place where physics groans under the weight of reality. And it reminds us, some parts of the universe weren't made for us to visit, only to observe and wonder. Inside a wormhole. Imagine a tunnel, not through space but through reality itself. This is a wormhole, one of the most mysterious concepts in theoretical physics. Also called an Einstein-Rosen bridge, a wormhole is a hypothetical shortcut through spacetime, connecting two distant points in the universe, or possibly two entirely different universes. Sounds like science fiction? It is, and yet it's grounded in real equations. Einstein's theory of general relativity doesn't forbid wormholes. In fact, it predicts them under certain extreme conditions, usually involving immense gravity and warped spacetime. But stepping inside one, that's where physics begins to fall apart. To stabilize a wormhole, you'd need something called negative energy, a form of exotic matter that doesn't behave like anything we know. This isn't just rare, it might not even be possible. Then there's the problem of time. According to some solutions, traveling through a wormhole could allow time travel, moving backward or forward along a closed time-like curve. Yes, that means go in one side and exit before you entered. This breaks causality, the principle that effects follow causes. If wormholes allow time loops, then reality itself becomes unstable. What happens to free will, to memory, to logic? These aren't just sci-fi questions. They're serious problems in modern physics. Worse still, even if you built a wormhole, keeping it open might be impossible. Quantum fluctuations could make it collapse the moment anything tries to pass through, like a cosmic mousetrap. And if it doesn't collapse, it might not take you where you expect. Some theorists suggest the other end of a wormhole might connect to a black hole, a white hole, or even nowhere. Not to mention, we don't even know what inside a wormhole would look like. Would it be dark? Would time still flow? Would space twist in on itself like a spiral? Would you still be you? Inside a wormhole, the very fabric of reality becomes unrecognizable. Geometry, time, energy, all the rules can shift. And that's why no known law of physics can fully explain what lies within. It may just be that wormholes aren't passageways, but warnings. The Planck Scale, where size breaks physics. There's something strange that happens when you make things really small. Not atom-sized, not even proton-sized. We're talking about the smallest scale in the entire universe, the Planck Scale, named after German physicist Max Planck. This is the point where distance and time become so tiny that our physics just stops making sense. The Planck length is about 1.6 times 10 to the power of negative 35 meters. To give you an idea, if a proton were the size of the Earth, the Planck length would be the size of a bacterium compared to the Earth. It's unimaginably small. So small that below this length, space and time may not even be continuous. They may become pixelated, like reality itself is made of little bits. This is where quantum mechanics and general relativity clash violently. At large scales, planets, stars, galaxies, Einstein's equations work beautifully. At small scales, atoms, particles, quantum theory takes over. But at the Planck scale, they both fail. Try to apply both theories at once and the math explodes. You get infinite energy, zero volume, divided by zero madness. Physicists believe this is the scale where we need a theory of everything. Something that unites gravity, quantum fields, time, energy, and information. But we don't have it. String theory tries. Loop quantum gravity tries. But so far, all attempts hit mathematical walls. Even worse, we have no way to look directly at the Planck scale. No microscope, no particle collider, not even our fastest light pulses can probe that deep. It's like the entire universe is built on a level of reality that we can't touch, only guess. It's as if, beneath the fabric of space itself, is a hidden code. And we don't know the language. Does reality emerge from pure information? Are we living inside a kind of simulation? Is space real or just an illusion built from quantum data? At the Planck scale, physics no longer describes nature, questions it. And if we ever crack this level, we may not just understand the universe, we might rewrite it. The edge of the observable universe. If you look far enough into the night sky, you're not just looking through space, you're looking back in time. Light takes time to travel. So when we observe distant galaxies, we're seeing them as they were billions of years ago. Some are so far, their light has taken nearly the entire age of the universe just to reach us. So, how far can we see? About 46.5 billion light-years in every direction. This boundary is known as the edge of the observable universe, the limit beyond which light hasn't had time to reach us since the Big Bang. But here's the weird part. This edge isn't the edge of the universe. It's just the edge of what we can observe. There could be more universe beyond it, infinite realms we can't see, where the laws of physics might be completely different. And near this edge, reality starts to get strange. Space isn't static, it's expanding. And not just expanding, it's accelerating. Galaxies at the farthest distances are receding faster than the speed of light. Yes, you heard that right, faster than light. How is that possible? Because it's not the galaxies moving through space, it's space itself stretching. And according to Einstein's equations, that's allowed. This leads to a bizarre consequence. There are regions of the universe that we can never reach, no matter how fast we travel, no matter how long we try. They are causally disconnected from us, permanently unreachable. Entire galaxies, perhaps civilizations, drifting into darkness, forever. At this edge, time dilates, light redshifts to invisibility, entropy grows, and the map of physics starts to fade. Do the constants of nature still hold true out there? Is gravity the same? Does quantum mechanics still apply? We simply don't know, and maybe we never will, because past this edge, we aren't just limited by technology, we're limited by reality itself. This is the place where physics doesn't just break. It ends. So what have we learned? That even in a universe built on laws, there are places where those laws don't apply. Where physics bends, where time twists, where reality becomes unrecognizable. Black holes, neutron stars, wormholes, the Planck scale, and the edge of the observable universe, each one is a reminder that our understanding of the cosmos is still painfully incomplete. And maybe that's the beauty of it. That mystery still exists, that some places are meant not to be solved, but to be wondered at. If this video shifted your perspective, even just a little, don't forget to like, share, and subscribe to the channel. We've only just begun exploring the unknown. There are more mysteries out there, and we're going to chase them together.